Bismillah ar-Rahman ar-Rahim. Well, students, last time we studied about reflection of light and the laws of reflection. Please recall those two topics. I hope you have made your notes and you have drawn the diagrams. Today's topic is about the reflection of light by spherical mirrors. You know, reflection of light as it takes place in case of plane mirrors, spherical surfaces also follow the phenomena of reflection of light, and the laws of reflection are valid on it. Recall the laws of reflection. The first one was that the incident ray, the reflected ray, and the normal at the point of incidence lie in the same plane, and the angle of incidence is equal to angle of reflection. In case of spherical mirrors, we'll take two kinds of spherical mirrors. The first one is the convex mirror. A convex mirror is one in which the outer surface is the reflecting surface. The outer surface is the reflecting surface. Suppose a ray of light, which is AO, is incident upon it at the point of incidence O and is reflected as OB. The angle of at this point O, draw a normal, that is a 90 degrees angle at this point O. The angle of incidence is the angle which is involved between the incident ray AO and the normal. So AON is the angle of incidence and the angle of reflection is NOB. OB is the reflected ray. R is the angle that is formed between the normal and the reflected ray. So in case of convex mirrors, the outer surface, which is the bulging surface, is the reflecting surface. So angle of incident I is equal to R. This proves that a spherical mirror also obeys the laws of reflection. Okay, now we take the second, in which we take a concave mirror. A concave mirror is one in which the inner surface, a concave mirror is like this, the inner surface is reflecting. The inner surface is reflecting. The outer surface is the polished surface. So you take a concave mirror, and in order to remember what is a concave, it looks like a cave. So concave mirror, AO is the incident ray and OB is the reflected ray. The angle of incidence is formed between the incident ray and the normal at the point of incidence. So angle AON, which is angle I, is the angle of incidence, and angle BON, which is the angle of reflection, R. Concave mirrors also obey the laws of reflection, and we will see that angle of incidence I is equal to angle of reflection, R. Now, there is a small activity 12.1 in your textbook which talks about it. It says that take a convex mirror, hold a pencil with a strip in the upright direction. Hold a pencil like this in front of the convex mirror and look at the image that is formed in the mirror. Try to find the nature of this image, whether it is erect, it is inverted, it is real, or it is virtual, large or small. I come again, take a convex mirror, hold a pencil in front of it with this tip pointing in the upright direction. Move it along the principal axis and try to find out the image. Guess the nature of the image. You will see that the nature in case of a convex mirror, the image is virtual, it is erect. All virtual images are erect. Always remember, an erect image is always a virtual image, and it gets diminished, it gets smaller as you move away from it. In case of concave mirror, this is a concave mirror, and you can also do an activity with this to find out what is the nature of, which we'll do after some time. The image location by spherical mirrors formula. Image location by spherical mirror formula. You know, you can find the distance of the object from the mirror, or the distance of the image from the mirror and the focal length by graphical method also, or by a ray diagram. A graphical method can also tell you the distance of the object from the mirror. It can also tell you about the distance of the image from the mirror and the focal length of that mirror. But another formula, another way of finding it out is by using the mirror formula. And what is a mirror formula? A mirror formula is the relationship. What is it? It is a relationship between object distance P. याद रखना हमेशा ऑब्जेक्ट का डिस्टेंस फ्रॉम द मिरर इज टेकन एज P, इसको हम P कहते हैं, एंड द इमेज डिस्टेंस फ्रॉम द मिरर इज टेकन एज Q. Always Q is always the distance of the image from the mirror and the focal length F. So what is the mirror formula? It is the relationship between P, Q and F. Simple, आसानी से याद रखने का तरीका है. मिरर फॉर्मूला क्या है? ये P, Q और F के दरमियान में एक रब्त पैदा करता है, एक ताल्लुक पैदा करता है. The relationship between P, Q and F is known as mirror formula. And P क्या होता है? P is the distance of the object from the mirror. Q क्या चीज़ है? Distance of the image from the mirror. And F क्या is the focal length of that mirror. Now this mirror formula 1 over F is equal to 1 over P plus 1 over Q. इसकी मदद से भी आप nature of image को मालूम कर सकते हैं. Image location ये टॉपिक है ही इस चीज़ का कि how to find the image with the help of the mirror formula. Okay. There are certain conventions regarding this signs key, and you have to remember this F is always positive for concave mirrors, and F is always negative for convex mirrors. P is always positive for real objects, and P is always negative for virtual objects. Q is always positive for real images, and Q is always negative for virtual images. So the sign convention is object distance P is positive for real objects and negative for virtual objects. Okay, P जो होगा ये प्लस लेंगे, साइन के साथ लेंगे, पॉजिटिव लेंगे रियल ऑब्जेक्ट्स के लिए. रियल ऑब्जेक्ट ऐसा ऑब्जेक्ट होता है जो कि जिसको आप स्क्रीन पे ला सकते हैं, और रियल इमेज वो जो स्क्रीन पे आ सकता है. कोई ऑब्जेक्ट जब आपने ऐसे उसके सामने एक पेंसिल रखी है तो ये रियल ऑब्जेक्ट है, लेकिन अगर ये पेंसिल किसी और मिरर का अक्स था जिसको उसने लेके ऑब्जेक्ट बना के आगे उसको मैग्नीफाई किया तो वो फिर उसको कहते हैं कि हम ये वर्चुअल था. सो रियल ऑब्जेक्ट डिस्टेंस P is taken as positive for real objects and negative for virtual objects. Image distance Q is positive for real, negative for virtual. Focal length F is positive for concave and negative for convex, always. Now activity 12.2, last time you used a convex mirror, you know, as it says, use a convex mirror, take a convex mirror. Now 12.2, we take a concave mirror and hold an object, say a pencil with this pointed side upwards, to get an image of something, say a tree or a building, a far off tree, and measure distance P, Q and F. Image nature, try to find out what is the nature of the image that is formed. Is it real, inverted or diminished? You have to find it out. This is activity 12.1, which concerns the concave mirrors, and this concerns the convex mirrors. So gentlemen, dear students, you have to revise this topic, make notes of it, draw headings, draw diagrams, neat and clean diagrams, label them properly as the incident ray, reflected ray, normal, angle of incidence, angle of reflection, and then draw the diagram of the mirror in this manner in which the reflecting surface is now concave as inside, so outside is a little bit shaded. Over here bulging surface is outside, which is reflecting surface, and inside is the polished surface. Make notes of it, and if you find any difficulty you can call me at these numbers, and please call me, feel free to call me and talk to me about any difficult point that is there, or if you need any guidance for that. But don't waste your time, get down to study. We have finished chapter simple harmonic motion, we have finished sound, now we are on the third chapter, geometrical optics. I hope you will give me the feedback for it. Thank you very much.